Sorry. Yeah, hi, Jenny. So we are 2 minutes into this right now. So it'd be great if you can kickstart this event.
Yeah, for sure. Thanks, Prem. Well, hello, everyone. Thank you guys so much for being here today, whatever time zone you're in. Good morning, good afternoon, good evening. This webinar is being hosted by one of our success teams, and hopefully we'll give you guys a great overview of the IDMC services available. I would also just like to thank you for being customers of Informatica. We really appreciate your investment in our product, and we just are really looking forward to working with you and bringing you success on the platform. We have a whole team of success managers. I lead customer success for Informatica globally, so our success managers are spread all across the globe. And really, their sole purpose is to help you be successful with your implementations, to provide you best practices, to get you technical help when you need it. And, you know, such as case in point with this webinar today. We'll also just be hosting some office hours after this webinar. So if you need to follow up or have a specific question for us, you can use those office hours to do that. And again, our success managers are here and available to answer your questions and also just guide you along the way, guide you along the journey. So I believe the webinar today is, if I'm not mistaken, Prem, we're going to be focusing on data integration, data quality, data governance, which are kind of three of the main pillars of the IDMC platform. But just again, thank you for attending this morning or today, and I hope you enjoy the webinar. And if you ever need anything from us, please feel free to reach out. So I'll hand it over to you, Prem.
Yeah, thank you, Jenny. Thank you. Hey, once again, good day, everyone. I think Jenny has laid out the whole thing very clearly. So we'll have this in 3 different sessions. Today's session is going to focus on data integration. This will be followed by the data governance next week and by MDM the week after. And again, we'll also have office hours. And at any point in time, if you want to, you can also reach out to the customer success managers. We'll be glad to help you move forward with your discovery into Informatica products. And Sachin, you want to take this over from me?
Yeah.
Thanks, Jenny.
Thanks, Jenny. Thanks, Prem, for the quick introduction. So yeah, good morning, good evening, good afternoon, folks. Let's get started then. I would like to introduce today's presenters. So Kinara Raghavendra, who is a principal solution architect, Ankit Tripathi, who is a senior solution architect, Gaurav Banerjee is again senior solution architect, and myself, Sachin Jain. So all are experienced with 15 plus years of experience, and then subject matter experts in data management, data integration, data governance concepts. With that, I would like to get started with IDMC, Intelligent Data Management on Cloud. It's a comprehensive cloud native and a clear AI-powered data management platform, which is designed to help you to manage and innovate your data in any platform, any cloud, multi-hybrid. And basically, this is designed to deliver the scale that you are looking at it actually. If you have huge volume of data, then the platform is ready to go to that scale and then deliver the way you are looking at it actually, right? Basically, it has different services, say data integration, governance, cataloging, democratize for marketplace, right? So MDM, and basically these are all the services which enables you to discover and understand your data, access and integrate your data across silos. Basically, business users are looking at how to orchestrate and then even automate the business processes. And most of that, how is our data looks like? Say, data quality, which is the basic and the main pillar of governance point of view and all, right? So it ensures the quality of your data, which is fit for the purpose, right? And also govern and protect your data as per the company policies, where we have the catalog and especially for the data governance services. And also it makes the data securely available to all the users with the help of our data marketplace, which is share and democratize actually, right? So, and we have connectivity for all the service, relational databases, file systems, mainframes, with many others, right? These are all the services. Now, today's sessions, so it will help you guys to understand how does our data integration services helps to solve different use cases, and probably I would say you can correlate your the use cases, and with the help of these services definitely you are able to solve the use cases and you should get the benefit out of it actually. Okay, with that I would like to hand over to Raghavendra to start with data integration services. Yeah.
Thank you. Can one of you confirm you're able to hear me?
Yes, Raghavendra.
Okay, thank you. Thank you very much, and good morning, good afternoon, good evening, wherever you are on the globe. In this slide, we are going to talk about cloud data integration, short for CDI, use cases, features, and benefits. The use cases here are primarily for cloud modernization initiatives that may be going on at your organizations, but it can also be used for any combinations of on-prem to cloud, multi-hybrids, single clouds, and so on. So the use cases mentioned here are not the be all and end all. It's just quick few pointers. The benefits. Before we go into the benefits of using the CDI service, you can use the expanded capabilities of CDI, for example, partitioning, push-down optimization, parameterization to increase your reusability within your development scope, and also get to GTM or get to your go live implementations that much more faster with the reusability. Having said that, we are going to concentrate on three primary features, which are advanced push-down optimization, Spark-based complex DI using advanced clusters, and the last one is advanced or serverless mode for CDI. So talking about PDO, the main benefit here is when you're doing ELT, like between cloud lake to lake, where the data is sitting within the same ecosystem and you want to do extract, load, and then transform. In this scenario, you can push the data flow definitions to the database engine or Spark serverless processing, cloud warehouse ecosystem pushdown, and various other options that are available. Essentially, your transformation logic gets converted into a form of a SQL query, which is then sent to the database for execution. Whatever is not converted, that gets processed within the usual engine or the secure agent processing. The amount of transformation logic that you can push will depend on the logic that you have used, the task configuration, and the type of database that you have, and so on. These caveats have been called out in our docs portal. That's, and the benefits of using APDO or advanced push-down optimization are the data is transformed on the database engine, more or less multi-processing or parallel processing that is available natively on the cloud warehouses and cloud databases, gives you that much more processing power with respect to scalability. And since you're within the same ecosystem, Cloud Lake ecosystem, there is no egress to speak of. Hence, the jobs will run that much more faster using less compute. So endpoint credits is the basic advantage that you are going to leverage here, right? Moving on to the advanced clusters or Spark-based DI. Here you can create elastic clusters to process data transformations or logic that you have. These clusters can be maintained on your behalf by a secure agent. We will talk about the types of clusters that you can create and so on. But here the clusters will be either managed by IDMC or your IT team. And these will scale up, or the infrastructure will scale up or down depending on your workloads or the volumes that you're processing at any given point in time. For ML or AI applications, you can use Python transformation to define basic to complex transformation functions here. Now, talking about different types of clusters that you can create within this advanced clusters. First one is fully managed cluster, wherein the secure agent will manage the entire Kubernetes lifecycle, which is startup, shutdown, scaling, and upgrades, right? Here, the agent will manage the compute infrastructure. Again, when we say agent will manage the compute infrastructure, you will have to give it as part of the settings in administrator UI. In the sense, this is how many EC2 instances I want to create for this cluster or for this data processing, and that is how many VMs will get created on the fly as part of this configuration. Now you can also leverage pod instances to further reduce costs when you are spinning up these instances. The fully managed clusters are supported or can be created in all the three ecosystems, namely AWS, Azure, and GCP. The second one is self-service cluster, or you can also call it as bring your own cluster. Here, the responsibility to manage a cluster lies with the customer. In the sense, you can use Amazon EC2 instances or Azure VMs, which in turn will use Amazon Elastic Kubernetes Service, which is also known as EKS, and Azure Kubernetes Service as well, right? The third one is local cluster. Again, this is a simple single node cluster that you can start on a secure agent that you're already using. Again, the assumption is that secure agent will be Linux. The local cluster is suitable for POCs to get you a quick hang of how the service works and so on, but is not recommended for production volumes. For production volumes, you will either have to go for fully managed cluster or self-managed cluster. At least that's our recommendation from Informatica, right? So that's about advanced clusters. Now, the third one is advanced serverless mode, right? All of these are features within Cloud DI with the same design pane. So don't think that these are different things that we are discussing here. So serverless mode provides a fully managed scale-out environment. You don't have to do any cloud administration in the sense cluster creation, cluster configuration, etc. No software that you need to install, set up. Here we are primarily talking about secure agent software, and no servers or clusters for you to actually manage, right? Or your teams to manage, your IT team to manage, right? So everything is handled by Informatica here. How do we do this? We create a secure serverless runtime environment is hosted in Informatica's VPC, which then connects to your AWS subscription via ENI or Elastic Network Interface. And that's how this works out. The processing happens between the two, right? And this is a single tenant and isolated model as opposed to all the other multi-tenant models that we have with respect to DI. This model provides you a dedicated server, VM resources to run your tasks in your organization, right? And this will also auto scale with respect to your size of the workload while your data still remains on your side of cloud ecosystem, which is AWS in this instance. The couple of caveats here. first one that we have already talked about, serverless will require your org or IDMC org to be in AWS environment, and your cloud subscription to also be in AWS for the ENI to work, right? And second thing is the VPC should have a default tenancy and not a dedicated instant tenancy for this to work. And the last one is a combination of the advanced cluster with the serverless. You marry the both, the cluster, the Spark-based data processing with the advanced serverless capabilities. You will now be able to, the serverless and runtime environment will now be managing your advanced cluster. In the former, it was Secure Agent that was managing. In this combination, your serverless RTE will manage the cluster for you. And all the workload changing, provisioning, deprovisioning of the resources, the worker nodes, high availability of the worker nodes to take care of your job performance and or failures, all of that is retained as part of this design. Right. These are the three primary features that I would like to present here. There are several others like advanced data transformation capabilities, which you may have seen, like hierarchy builders, parsers, and processors. There are also Apache velocity transformations, etc., which can convert between hierarchical schemas that you may have, right? And using ISD or intelligent structured discovery, which is again based off of a clear engine, which this will automatically parse your complex file systems. Here we are referring to Parquet, Avro, and so on. You can also detect data fluctuations here in your files and clicks in data, right? CDI also has rich set of connectors in addition to transformations, right? Using which you can connect to all your data sources. Out-of-the-box connectivity is also provided to many cloud, on-prem systems, enterprise, and middleware applications, SAP, Salesforce, and data stores, for example, Blob, S3, and so on in the AWS ecosystem. And many other support for many other analytical and BI tools that we have, right? That's what I had for CDI. Can you click next? Sorry, yeah, thank you. So what we talked about, the single mapping designer pane that you are going to get is the look and feel of it is much of the same between the different modes that you're going to develop your mappings with. And the last one is for task flow orchestration. This is nothing but where you're going to manage and control your interdependencies between the various tasks that you may have to process or to do data processing for an application or for a given project, right? That pretty much summarizes what CDI does. Shall we go on to related services, or are we doing Q&A in between, Sachin?
Yeah, we can take up the Q&A probably at the end. We can.
Okay.
Great. Yeah.
Okay, let me start off with the related services. So with CDI, you need a few other services, all right? Here we called out those services. For administrator service, right? This is kind of a place where you're going to create your source and target connections, your schedules, your configuration for source control, your runtime continuity settings, configuring object permissions, user administration, creating and configuring runtime environments. When we say runtime environments, we are referring to the normal Secure Agent deployment, the cluster deployment, as well as the serverless deployment here. So everything that you want to do with respect to creation and configuration, with respect to the environment, this is where you're going to do all of that, right? And the connections that you're going to create are then referenced in the mapping designer, where you're going to call the sources and targets, and then the transformations in between. So this is where the administrator service gets used. This is a common service as well, which has interdependencies for other services that are going to be presented in this session after me, and also further future sessions next week and the coming week as well, right? One such other common service is the monitor, right? This is where you're going to view and monitor your jobs, the imports and export of assets that you do, the source control logs that you can go through, the at scale clusters, the various actions that you may have performed. You can monitor the progress of all those actions that you have performed. In addition to that, you can also download log files for troubleshooting for errors or liaising with our info support, right? So this is another common service that gets leveraged across IDMC platform, not necessarily for CDI alone, right? And the third one is operational insights. This is where you can, in addition to monitoring and viewing of the jobs, but operational insights was primarily built to give analytics behind behind the job performance themselves, and to increase operational efficiency of your Informatica infrastructure. For example, we are referring to here the secure agent infrastructure that you have. It also can, you can also leverage this service to monitor your on-prem service as well, but that's beyond the scope of this session. But you can do all of that with this service. With the service, you can also monitor or analyze the job performance for not just CDI, as we were talking about, CAI, which is application integration, mass ingestion, and much, much more. The capabilities of operational insights are increasing with every quarter we roll off our upgrades. These are the three common services that we have. The other three are dependents, either in a parent-child relationship, right? You can integrate or call CDI tasks in cloud application integration processes via run cloud tasks in service step. This is to basically provide the native integration between CDI and DI, which is the data integration layer, and the application integration service that we have. And the reverse is also possible, meaning you can call a published application integration process in a CDI task flow via integration ops step, right? So the native integration between the data integration and application integration is possible at a task level, right? Coming to the cloud integration hub, you can use the CDI tasks or call CDI tasks as part of your publications and subscriptions. You will kind of hear more when one of my colleagues starts presenting the integration hub slide, and you'll gather more information on that. And likewise, you can also call data quality assets, cleanse, dedupe, labeler, parser, to name a few, as part of a CDI mapping or a maplet. That way you can encapsulate your data quality assets or data quality logic within a mapping. And then you can show output as this is what happened after my data processed, and so on and so forth. You will learn more on the data quality in our next session when data governance session starts. So that's what I have for cloud data integration and related services for that. So with that, I will pass the presentation to Ankit for CAI presentation.
Thanks, Raghvind. If you can confirm if I'm audible.
Yes.
Yeah, you are.
Okay.
Right. Thanks, Sachin. All right. So welcome to this overview session for cloud application integration. As the name suggests, it's the service which we have through which we are able to integrate applications. The cloud data integration service, which Raghvind talked about just now, is meant more for batch integration, where we are doing tons of data integration or migration from one data lake to another data warehouse, as we talked about. But this specific application integration microservice tries to solve the problem statement where a real-time integration between application is concerned, as well as when we are trying to create a pipeline or a data pipeline with trickle feed data. That means the execution time or the timeline for a certain data to be encapsulated by another application is very short, as well as the number of records which we are trying to integrate between applications is also very less. As the name suggests, as I said, application integration, by the virtue of the name itself, we are able to create integrations between applications, and these applications can then be deployed on, or the nature of these applications or integrations can be cloud-based or on your secure agent as well. Now, with the capabilities and the use cases which cloud application integration has to offer, I would first like to talk about process integration, and I will also like to talk about certain use cases which are associated with process integration. Process integration, basically, as I just talked about, it is integration between application. Because we are able to get the needs or get the data from one application which is exposed as an API or OData, we are able to read those APIs or call those APIs and then parse the data in such a way that we can transform it so that our other applications are able to understand it. And that is where we are able to come up with a business process which is able to essentially solve a problem statement like an employee onboarding system. Now, when an employee is onboarded in any company or in an organization, there is a ton of steps which needs to be performed. Now, because this has to be performed for every single employee, this is a perfect scenario where a process integration or a business process can be created, which can be completely automated, meaning that all those tons of steps which needs to be happening for a single employee can happen without any manual intervention on its own via a process flow within cloud application integration. On the same scenario, let's say, for example, we have a scenario where some sort of an input is required from a human. We can also accommodate this particular scenario with a certain concept called as human tasks within application integration. What happens in those scenarios is, let's say, for example, the employee process got kicked off, but in between it requires some information to be fed in by an individual, or the information which has already started as an automated process, this needs to be reviewed by an individual. In this particular flow, we have something called as human tasks, which can then wait for a human intervention to complete, and then the whole process can from that point onwards go on as an automated process. So we are able to leverage cloud application integration in both the scenarios where automate and integrate business processes is the need of the hour, as well as automating user workflows with interactive access of data, which is the human tasks which we talked about. Now, process integration is just one capability and one use case. But another use case or the capability which we have within CEI is basically real-time API and event-based integration. Now, the business process which we just talked about, this can trigger on its own, meaning that every business process which is created in application integration, it is published as an API, as a bare endpoint. So you can call them as and when your source application want them to be called upon, meaning that you can code those API to be called on a certain event in your source application. A classic example could be, let's say, your source application being a custom application where a certain user is, let's say, saving an opportunity. Let's say, for example, in Salesforce, a user is winning an opportunity and it is changing the status of the opportunity to one closed. At that point of time, you can hook up to that particular API so that it can take all the inputs for an opportunity as input parameters for that API. And you have, because you've already created the business process flow to accept those input parameter and probably provide that particular information of opportunity related to one opportunity to a downstream application, you can essentially do that via an API call to all those applications again within the same business process flow. Now, all this can happen at real time. You don't need to have any human intervention in place. Now, the same business process flow, but let's say you don't have to rely on a certain event. Let's say your event is happening on a business, on a message queue like Kafka, or even AMQP protocol. Then the same business process flow can be hooked up to a message streaming service via an event. So how those business process flow will trigger is basically the as and when the data is provided in those topics or queues, the process flow or the business process flow can trigger on its own. Again, there is no human intervention required. These are the two benefits. Now, the third one being the API implementation and management. Now, let's say, for example, the business process flow which you just had, and because it's a bare endpoint which Informatica allows you to have once you publish the process flow, in the real world scenario, this almost doesn't really flow through because we are in an era where the data security plays a very important role. And that is where API management comes into picture, meaning that the bare endpoints can now be published or can now be managed, and you can apply all your policies onto those business processes, meaning that you can apply what location those APIs can be called upon, how many physical locations they can be called upon, how many users can call it, and also how many times they can call it. So all this API management is something which we also provide as part of API Manager. These are all sister services of Cloud Application Integration, where they work in tandem to provide you with a complete solution of creating an API as a real-time API, and also you can apply your policies by making the use of API Manager so that you can create a managed API on your own. You basically don't require any admin knowledge beforehand. You just need to understand how the API Manager is able to read those APIs as managed APIs, apply IP whitelisting, or not whitelisting, but IP restriction on those APIs so that those APIs can be called upon certain locations only. So these are the three capabilities and the three use cases which I talked about. But in addition to that, the CAI application works well with front office and back office application integration, like order processing, financial and inventory management, wherever the propagation of Salesforce order, which I talked about, can be done, or any financial product and customer data to SAP integration in real time. CAI application itself, we have been able to do real-time sync of accounts, quotes, and product. We do well with the syncing of accounts between Siebel and Salesforce, as well as Oracle and Salesforce. Just like cloud data integration, we are able to touch upon any application which you exposes the data as an API, or if your end product is basically a database or a data warehouse, we can connect to them via the JDBC connection, which is again a connection available within the premises of cloud application integration. So in a nutshell, what problem statement we are trying to solve with the application integration is the applications tends to have the data that it requires, but those requirements can overlap with each other. Most systems are not built in a manner that they can work together effectively. So we CAI specifically with business process or process integration is able to provide that platform so that different APIs can talk to each other at the same time. They can wait for another API to complete its job so that they can get the response back and then move ahead in the business process. So this is the problem statement which cloud application integration is basically trying to solve. Operational insight is again tied back with cloud application integration because it can give you a certain analytics dashboard of how many times an API has been called in addition to API Manager. So all this is tightly integrated with the sister services as well as other services within IDMC. As Raghavan talked about, CEI can call data task, that is mapping task within CDI, but there is a specific use case which should be used for this particular task, and we encourage you to basically invest and try to understand more in detail about cloud application integration if you are trying to solve a problem statement which is similar to what we have discussed so far. The the UI page which you see on the screen is something which is very similar to task flow within CDI. So if you already have a little bit of a knowledge on data integration, task flow, it will be very easy for you to orchestrate a flow within CAI process flow, although it has its own capabilities, which is more related to API knowledge. So as long as you have the API implementation knowledge, I think the adoption of the service becomes more easy for anyone. Um, with this, I think that's the whole lot of information which I had for application integration. I would like to talk about now is Cloud Integration Hub. So it's a cloud-based application solution that you can use to share and synchronize data between a different application in an organization. What problem statement this tries to solve is, let's say when you start your integration solutions, you started with a point-to-point integration and you created two sources and you started point-to-point integration between the two sources. But what happens when you come to a solution to a scenario where the same information or the same sort of data is being asked by another application? So what you do or what you did in this scenario was essentially create one more point-to-point integration. With growing needs of different application wants the same data again and again, what you end up with is a very complex point-to-point integration landscape, which is not easy to manage. Your developers and your team leads don't really have a single view of where the data is going. You are then relying on certain documentation which your team may or may not have created to understand those integrations. So this CIH application tries to solve this particular problem statement where we move away from point-to-point integration and move towards something called as hub and spoke architecture, where a publication asset can be used to publish the data from your source application into a hub repository. Now, this particular data which has been sent to a hub repository can then be asked upon the latency which they desire by the subscribing application. That is where the subscription part comes into picture, and that is where the spoke part of the hub and spoke architecture is more relevant. So with CIH we are able to provide hub and spoke architecture where a publishing application publishes the data once from your source application, and your subscribing applications can make use of the subscription asset and call or request for that same data, not just once, again and again, but what problem it is solving is, it is decoupling your source based on the number of sourcing applications or subscribing applications with the same data, meaning that you're not calling a publication job again and again, because now you have a staging layer in your hub which is storing the data. And no matter how many applications wants the data, you will only pull the data once from your publishing application, and your subscribing application will then get the same data as and when they want. A use case which comes to my mind is again related to it could be related to Salesforce, where let's say your sales representatives have been on a spree where many accounts have been added or many leads have been added into your Salesforce system, and your other systems, let's say for example a marketing system, wants the same data as of now, but going 3 months down the line, your another application might want the same data for your analytical purpose, maybe to understand why this lead was not converted, or why this lead was converted, and probably effectively deduce as to what went right or what went wrong. So what you could do in this scenario is you can write a daily job with data integration as the underlying layer for your publication, and you can pull the data only once through that job, a publication job from Salesforce. So it will reduce the API overhead on your Salesforce application, and then your subscribing application can then subscribe to that same data which is in Hub uh, at any latency, which I talked about before. Now, because CIH is tightly coupled with CDI as well as cloud application integration, or you can actually subscribe the data as an API. So this CIH subscription also allows you to subscribe the data as an endpoint where your subscribing application can look for a webhook within subscription. And as soon as the webhook is hit, that means the data has been published, and this information then cascades to your subscribing application, and then those subscribing application can call those APIs as and when they want. The APIs which are exposed by CIH again is pretty extensive, meaning that you can call or you can make those API call to get the latest data. You can make the call to get the whole data, or if you have already subscribed the data once, you can also get the same data again and again as and when you want. So in a way, we are with this CIH application or microservice, the problem statement which we are trying to solve is to make sure that you move away from point-to-point integration and move towards a more reliable and easy to manage solution, which is a hub and spoke architecture. And with Monitor, as well as within the CIH service, you get the complete control as in, let's say, for example, if you're subscribing assets fail for a certain reason, you have the option of retrying or configuring the subscription of assets with retry configuration, meaning 3 times or 5 times, whichever you choose. And also have a single view of how much data has been published, how many applications have accepted the data, that same data. So you get a full view of how much data has been flowing around from your uh, publishing applications to your subscribing application. With this, I think that is what I had for CIH. I would like to transfer my thing to Gaurav Banerjee for cloud mass ingestion.
Thanks, Ankit.
Over to you, Gaurav. Thank you.
Thanks. Hello, good morning, good evening, or good afternoon, everyone. So regarding the cloud mass ingestion service within the platform, it is basically, as the name suggests, that it requires, if there is a use case or a requirement to ingest a large amount of data with a minimal latency time, then that is something which this particular microservice covers with ease. So on this on a high level, and when we get into the details of mass ingestion, so basically the use case, as I said, that it does the whole ingestion of the data within a short span of time, and also the requirement of having to manually look into the data every time whenever there is an availability, and extract that data on the ZDC data basically on a particular frequency on an incremental basis. That also is taken care of, and the users do not need to run a batch job to get their data and get the CDC data and then load it into their target system. So essentially, this covers this brings in a benefit of two on a high level. One, that the volume of data which it processes within the period of time, that is considerably lower than the other microservices, and It also gives a real-time integration feel where the users do not need to look into the CDC data and capture them, run them on a batch processing level. So it gives a real-time execution of that as well, right? Having that said, the use cases which basically should be or ideally are meant for the cloud mass ingestion microservice is to ingest the data. And when I say that, the prime objective is first to bring the data from the applications or maybe databases, or in the form of files. So whatever it is, bring the data, put that into a form of a data lake, and or if you want to call that as a delta lake, whatever it is, and then use that data to do your analysis or run your algorithms on top of it, which might require a separate set of programming. But the major part, which takes time and effort to bring the data, is taken care of using mass ingestion service. This is on a high level. Now, getting to the details of it, this mass ingestion is typically divided into four broad categories, depending on the data it processes. So, as I said, that mass ingestion can pull in data. So, you might have your data in the form of files residing in some local storage or in some FTP or SFTP locations, which need to be brought into and extracted and loaded that into a data lake. That kind of scenario requires creation of a file mass ingestion category within the mass ingestion service. That is the file mass ingestion. Second category is the database mass ingestion, where the data is residing in the form of database tables. The examples could be like Oracle, SQL Server, Postgres, right? So these databases have been around for quite a long period of time and accumulated a large amount of data as and when the business has grown. So bringing in this amount of data is not an easy task. So for that, this mass ingestion comes into play and does this. So the category which needs to be selected for this is the database mass ingestion. The third category is streaming mass ingestion, which deals with streaming data, where the data is in the form of message queues. It can arrive on basically from the message queue, and that needs to be processed and loaded into the data lake. So that calls for a streaming mass ingestion. And the fourth category under the mass ingestion umbrella is application ingestion. So I might have my data which is coming in from different applications, which is it's not typically into a file or into a database. So what happens is that if my data is residing in a Workday application or a Salesforce application, and there is a hop which requires you to basically bring that in the form of a file and then use the microservice. No, that is not required. So you would directly call that or connect with that application directly, let's say Salesforce or Workday, and then bring your data into your data lake, right? So these are the four categories under the mass ingestion umbrella. So if you look at the points, it replicates the data from objects in SaaS on-prem. So basically, it does not discriminate. You can have your data residing in on-prem or in SaaS or in cloud-based lakes. You can bring your data from all these places into your data lake. Okay. And you can have in event streaming platforms as well. It replicates the data, and please mind that I'm only replicating the data and I'm not making any transformations here, because that is not the objective. The objective is to bring the data first and then run your algorithms on top of it. right? Replicates the data from objects in RDBMS, transfers a large amount of files or data residing in databases or applications with a real-time flavor. In case if you are opting for a CDC data, and it does all of it. So these are all the typical use cases, right? The benefit which you get out of this is that your latency time gets reduced. Okay, you do not need to wait for a large amount of time to bring your data. Okay, your data is there. You get the real-time benefit. Okay, you do not need to sit and then monitor whether your data which you are bringing in has already arrived in the source system, and you need to run your batch process. No, it does it automatically, right? Then basically it's a easy four-step wizard of creating the whole job. Okay, there is not much of a programming or understanding of the programs which is required. You just select your sources, your targets, set the properties, and you are done, right? The data ingestion with a single unified cloud native data ingestion solution. So what you can do is, let's say, out of these four categories which you have spoken about, the file mass ingestion is the only category within the mass ingestion service which can be integrated with the data integration. And in case there's one other thing which I wanted to mention here is that in using a single job, you can pull multiple objects or multiple files or multiple tables. You can select them. Okay, you can use a wildcard in the job level itself. You can use a regex or a wildcard, and then you can point to multiple objects so that you do not need to create multiple jobs for that, right? So it does that. Now coming to the real time or the CDC part of it. So mass ingestion job is divided into three. Any mass ingestion job is divided into three levels of types. Okay, so one of the types is where the mass ingestion job which you create does only initial load. Okay, so basically you bring in your historical data and then put that into your data lake. That is plain and simple. It does only that. The second one is it does when you select your mass ingestion job to do the incremental load. So incrementally, you can bring in a CDC data without any intervention of any kind, and it will keep on looking for the arrival of the data, bring in that data, and store that into your data lake. And the third category is a combination of it. So you can have initial load for the first run, and from the subsequent runs, it will do a CDC load or an incremental load. So these are the three types of mass ingestion jobs, right? So just to summarize all of it, using this mass ingestion, you can do this whole lot of steps with a lower latency, right? Jumping into the next service, which is Cloud Assurance Package. This service will basically do kind of on a high level, it does a health check for you, right? So how your system is performing on various parameters. And when I say that, you can basically look into your assurance score. Okay, based on that, you can decide whether your system is performing well, whether it is able to capture or process this whole data integrations or any service which you run with ease, or is there anything which you need to look into, right? So you have specifically different categories within Cloud App Assurance Package, where health check, you can analyze your logs. You can do your configurations where you need to modify the parameters based on which you are running your assurance package on the backend, right? So all of this will assess your existing system, your runtime environment basically, and then give you a respective score where let's say the use case could be that if there is an upgrade which is happening and you need to find out which all the jobs which you have are impacted out of because of that, you can very well get that report from the assurance package. Okay, it will do an impact analysis. It will let you know and identify what you need to do. Right. There is a health assessment which I already talked about. So these are all the use cases which calls for an assurance package service. The benefits are that this is intelligent. You get it all of it in the platform level itself. Okay, the volume projections. Okay, the naming conventions. If there is any a disparity where your naming conventions are not followed, if there is any entity comparisons which you, let's say you want to compare to mappings or the mapping tasks, you can do it in the cloud assurance package. It will compare and give you the differences if there are any, right? And definitely the assurance score, which is an AI computed score. It checks various parameters and then it will give you a whole level score, right? So coming to the next service, which is InfraCore. InfraCore is basically an open kind of a programming kind of a, environment which it gives you, where you can do your own level of programming to bring in your data from the sources and targets which it supports. Okay, so it has like 70 plus or close to 70 kind of connections which it supports, and you can bring in your data from all of them and with a programming touch. So there are two aspects to it. One where you can build your own program, and the other with the SDKs basically. So it relies on the Python SDK, and you can build your own program based on that. And the other aspect is where with a low code kind of thing, where you build you install the extensions in the Jupyter Lab, and then you write the program in the backend while you do the selections in the front end, right? So this is basically what the InfraCode does, and it will give you, the use cases which you get out of it is that you can bring in your data, you can create data sources, you can convert that into Panda, right? And also, like if you want to transform or basically flatten your data from an unstructured or a semi-structured format, then you can do it with ease. We have functions which it supports. And since this is embedded with Python, which is very lightweight, and it does not consume any of it if the system supports it, right? So it's robust. It boosts the developer productivity with the extensions and the SDKs which it comes along with in the kit, and it leverages rapid programming and maximum reusability of data assets to promote better collaboration between the data teams. So this is what the InfraCore has to offer, and it's a rich set of connections which it supports, which you can leverage and build your code.
Thanks, Gaurav. I think we can go for
Thanks,
Q&A. I think we are on top of the hour. I think guys can please post your questions. Any questions or anything, feel free to post it. So we are happy to answer that. I think there were a lot of questions against, like, to share some of the deck. Definitely, we will be sending it across to you guys. There was one question, how to navigate to InfraCore. Raghavendra?
Yeah, I'm just answering that. So
Yeah.
you have an installation steps. I'll just say that over here. So you have a set of installation steps which you need to follow, and that where you can basically install the libraries. So you do not need to do anything. You might have the Python already installed. Would need to install the SDKs, the libraries, and then you can use it along with it. In case if you are looking for an extension, the Jupyter Lab extension, you can do that as well. Okay, and it supports Jupyter Lab and Databricks at the time being.
Great. Thanks, Gaurav. And there was one question that this recorded session will be available. Yes. So this is recorded and then this is made available for you guys. Yeah, thanks. Doc links. Yes, Ankit has provided the doc link to you guys. Any other questions? Please post your questions, guys. Okay, we'll have 1 more minute for any sort of question and answers. And again, we will be conducting office hours for Q&A also. And if you guys need in-depth demo sessions or probably detailed sessions, or to basically to go over different use cases, please reach out to your CSMs and then the expert will get in touch with you guys to go with the use cases discovery call to understand what use cases you guys have. And then probably we will map it to our IDMC platform and then probably you can build based on that. Okay. Thanks, Gaurav, for providing all the documents regarding Infaco. Okay, so if there are no more questions, then probably we are good to close it off. Thanks a lot. Thanks, guys, for attending these sessions. Have a good day. Good evening.
Thanks, everyone.
Thank you. Bye-bye.
All right.
Thank
Thanks,
you,
everyone.
everyone.
Have a great rest
Have
of
a
your
good day.
day.